Hi, welcome back, Algebra 2 friends. This is our lesson on how to graph a couple of radical functions. It's not all of them, but we're going to focus mainly on the square root function and the cube root function. And we're going to talk about some overlapping concepts to a previous lesson regarding transformations, some domain and range questions, and it's just a new type of function that we're talking about in Algebra 2. So we just got done with a lesson on graphing absolute value functions. And if you remember, our absolute value function of absolute value of x minus 2 minus 3, and I asked you for the transformations to that function, well, we determined that it was shifted right 2, which I know surprised some of us because we were thinking left 2, but there's a built-in negative there. And it was also shifted down 3. So those transformations you're going to see are common between all of our functions. And we have today what's called a square root graph, and it's got the same idea going on. So when you see the square root of x minus 2, that again is a right 2 shift. And then when there's a subtract 3 on the end of the function, again, that's going to be a down 3. Now this might be news to you, but a square root function looks like this. So it doesn't have a vertex necessarily, but I call this origination point. Usually it starts at the origin, and then it kind of does this weird like side bend shape. So this particular square root function was shifted right 2, down 3, and now it looks like this. So that's nice when things in math kind of cross over to the next lesson. So we're going to, same idea here, we're going to identify the transformations, and I'm going to try to keep my colors straight here. So remember, there is a built-in negative underneath the square root piece of the function, just like there was in the absolute value graph. So this right here is a shift of right 1. And then over here we have an up 2. Oops, I didn't finish that. Up 2, right 1. All right, be careful on this one though. This has a couple of transformations, 3 of them actually. So let's first talk about the left 3. And then we have a down 4. But there's something else we haven't talked about yet today, and that would be the fact that there's a negative in front of it. Remember, we called that a reflection over the x-axis. Now, I will warn you, because I do teach pre-calc, the reflection over the x-axis actually happens before the downshift as far as like order of transformations. I'm not going to harp on you about that here for Algebra 2, but if you move on to an upper level math class, the reflection is going to occur before the downshift. I know it doesn't probably make a lot of sense right now, but they do have to happen in the right order. So this next question, same idea. We've got 3 things to think about. We've got this 5 in front. And then we have the square root of x plus 4. And then we have a plus 3 over here. So this time I'll talk about the vertical stretch. Oops, spoiler alert. Vertical stretch of 5 first. Oops. And it's a stretch this time because it's greater than 1. The x plus 4 underneath the square root symbol means we're going to shift left 4. And then we have an up 3 shift at the end. So again, for Algebra 2, the order, I'm not going to yell at you if you get the order wrong, but for pre-calc, it is going to make a big difference. Oh, and we have a special guest with us now. Logan Abruzzo. There you are, buddy.
What are we doing?
We're going to be graphing square root and cube root graphs. Okay, here we go. First, the square root graph. Now remember, we have a really cool calculator that can help you. Mm-hmm. So those of you on your calculator, your computers, your Chromebooks, you can use that emulator. And in y equals, we're going to type in the square root of x.
Okay.
Now, if you have a weird window for some reason, remember you can hit zoom 6 to bring you back to the standard viewing window. And that is the square root graph. What does that look like to you?
A straight, bumpy road line.
Totally. All right, so if we go to the table.
Bye again.
Bye. If we go to the table, something interesting happens if you kind of scroll backwards in the table and it starts giving you errors. That's because the square root function is not defined for real numbers beyond a certain point. And let's think about that from an algebraic standpoint. We're taking the square root as an output, okay? So I noticed on the table the first number that worked for x's was 0. And when you took the square to 0, you got a 0. And then if you plug in a 1 and you take the square root, you get a 1. And then in that same table, if you took the square root of 2 or 3, they were icky numbers. I'm not going to write that down. But if we took the square root of a 4, it comes out to a 2. And if you took the square root of 9, that came out to a 3. So those were just some nice ordered pairs that we came up with either in our brain or on our calculator. And if we graph those, the important thing is that we went as far back into the table as we possibly could right before the errors started, because that origination point has to be graphed. Otherwise, we don't really have an accurate graph. And then he's right. It is kind of like a weird, bumpy, it's actually pretty smooth. It's like a half of a parabola on its side, if that makes any sense to you. So now let's talk about domain and range, remembering that domain is a set of all your x values as an interval from left to right. So this particular function starts as 0, and there is an ordered pair at 0, so we're still going to use a bracket. And then it kind of goes off to the right forever towards infinity. Always use parenthesis infinity. And then our range, remember, is low to high. Ugh. So remembering that I have to measure it in that direction, my range starts at a height of 0 as well, and then goes off to infinity. It goes up to infinity. It goes up really slowly, but it does increase forever. So that's interesting. So that, my friends, is your square root graph. That's the parent function to the square root graph. Now let's talk about the cube root graph. Well, again, if we go to our calculator and get a little inspiration here, and remember, we do have that chart of perfect cubes that you can use backwards to figure out cube roots, just FYI. So cube root is in the math menu. Number 4 is the programmed for cube root. And then if we look at that picture, it's a weird looking picture. Hey, Lo, you coming back?
Mm-hmm.
Yeah, what do you think that graph looks like? Does that look like anything to you?
If that's a body, it would be like weird arms, like.
You're right. It would be. Yeah, it's like doing that. All right, so if we look at our table, you'll notice this time this is a continuous function and there's no errors that occur as you go negative, because you can take the cube root of negative numbers, so that's nice. I'm going from the old noggin here. I don't need to go to my calculator, but right away you probably saw like 0, 0, because this cube root of 0 is 0. I also noticed surrounding 0, 0 was 1 and negative 1, which both gave you nice points. We're going to call those nice points. So the cube root of negative 1 is also negative 1, and the cube root of 1 is 1. And then if I kind of keep heading back in the table, I think we stumbled on negative 8 and positive 8. Those produce nice points because the cube root of negative 8 is negative 2, and the cube root of 8 is a 2. You knew that? Smart. All right, so we're going to be plotting those. So negative 8, negative 2, negative 1, negative 1, 0, 0. And these are probably one of the worst things for me to graph. These are very difficult for me. So I'm going to try to make it look like a body with its weird arms. All right, here goes. Almost got it. So close. All right, so we do have that continuity. Now, this is really going to mess with you guys because you're going to remember domain and range again. Domain's pretty obvious. It looks like it's going forever, so left to right would be negative infinity to infinity. But for range, it does also go forever low to high. So the range also goes from negative infinity to infinity, just super duper fast. Or slow, not fast. Opposite of that. It's opposite day, Logan.
What?
It's not. I'm kidding. I'm just dyslexic. All right, so range. There we go. Goes forever from negative infinity to infinity. You know, it would be nice if you had those memorized because then we wouldn't have to grab the calculator every time. But you know what? If we have to grab the calculator, that's fine. So I think a good way to start this question would be talking about transformation. So we know what to expect, even if we're using a calculator. If we see x plus 5 underneath the square root sign here, that means, remember, there's opposite factors here. This is really a left 5 shift. And then we have this subtract 2 off to the back end here. That means everything's going to shift down 2. And if this was a matching problem, like match which graph, works for this, which they do a lot on the SAT test. Remember, the square root is going to look like this. That's the shape of the square root function. So we'd just be looking for something that was shifted left 5 and down 2. If I want a more accurate picture, though, I'm going to have to come up with some good points. So what I'm going to do...
Make a rainbow.
Make a rainbow?
Yeah.
No, I'm going to cheat and use my calculator.
Wait, you're gonna cheat?
It's not cheating. It's using your resources. All right, so square root of x plus 5 and then a subtract 2. Make sure you use a subtraction symbol and not a negative symbol. Now square roots, you got to go back and look the first time you didn't have an error because that's your first point. So no surprise here, negative 5, negative 2. And then we got negative 4, negative 1, and negative 1, 0. I'm not going to remember those. Can you help me?
No, I haven't been
Listening? Yeah, they haven't either. Just kidding. I know you have. All right, negative 5, negative 2, negative 4, negative 1, and negative 1, 0, I believe were the points. So I steal those points and I graph them.
Down 2, left 5. Up there, 1, 0, 4, 4, 1, 5, 2, X, Y?
Yes. All right, so there's our graph. The domain, remember, is left to right, your x values. So it starts here at negative 5 with an ordered pair.
Huh?
And then we'll try to make a connection to this in a minute. And then your range. Oh, I hate writing sideways.
So no range?
Range. Range is low to high y values. All right, so it starts as low as negative 2 to infinity. Now, we kind of talked earlier in the absolute value lesson about how we could kind of bring these thoughts together here, guys. Your h value, or your horizontal shift of left 5, has something to do with the domain for square root graphs.
Okay, I don't get it.
And then your k value, your down 2, has something to do with your range. So as I'm taking my test on these questions, I'm just making sure everything's matching up. You know, shifting left 5 makes my domain start at negative 5.
Shifting left 5.
Right. So this one, not my favorite problem because it's a cube root graph. And you know I don't graph these very well.
Do some good points.
We need to get some good points. Now, before we get those good points, let's talk about the transformations again. So cube root of x plus 2, remember opposite factors in the cube root, that is going to be a left 2. And then this plus 1 out to the side of it is going to shift it up 1. So if I was matching everything, I'd have to remember that the cube root function is the one that does that weird S squiggle shape, right? The weird arm.
Squiggle bellow bill.
Exactly. So I'd be looking for something that was shifted left 2 and up 1. But, you know, I'm going to use my resources here and grab my calculator.
Your resource.
My resource. Try that again. All right. Y equals, gotta go do a cube root this time, Log. That was not what I wanted. All right. Cube root. I forgot what it was. Was it left? Okay. X plus 2. And then get out of the cube root before you hit a plus 1.
Okay. I still don't get it.
Still don't get it?
Because I'm only second.
I know. All right, so I'm looking for nice points. I don't want any decimals. So there's a nice point. Negative 10, negative 1. And
4?
then, well, it's got to have a nice part over here as well. So how about negative 3, 0? And, oh, no. I didn't mean to do that. Negative 3, 0, negative 2, 1, negative 1, 2. I'm not going to remember those. All right, negative 10, 1. Negative 1, hello. All right, remember these. Negative 3, 0, negative 2, 1. Oh boy, here we go. And then we really should get...
What the...
I'm drawing on my calculator. Oh, Mom. Usually there's a nice... 5 points is what I really, really want. So negative 1, 2, and 6, 3. If you can get all 5 of those points, then you're going to have a really good picture. Sometimes you can't graph them all, but at least write them down. So negative 2, negative 1, negative 3, 0. Negative 2, 1. Negative 1, 2. And 6, 3. Oh, man.
3.
I don't stand a chance in graphing this well.
I can do it well.
Oh, yeah? Oh, so I didn't even hit that point. Okay. Pretend So the good thing about cube roots, even though they're horrible to graph, the domain and range are very easy. The domain goes forever and the range goes forever. And they always will for cube root graphs. So that's excellent news. That's probably the only good thing about cube roots. They're not my favorite, that's for sure.
Okay, 2, 1, 6, 3, something, 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 something.
Helpful. Okay, so we're back to a square root graph. Boy. All right. So this time I'm going to show you what it looks like to do it without a calculator at all. This is not super fun. I'm just going to warn you. So first thing to remind myself about is a square root graph normally looks like this. But this one has a couple of transformations. It has, first of all, it's got a negative in front. So it's going to have a reflection.
Reflection.
And I'm going to write over the x-axis just to be really special.
X-axis.
And then this is going to be shifted left 1. And then this will shift it up 3.
Left 1 up 3.
That probably busted everyone's eardrums. Don't do that. All right. So a lot of things are happening here. First thing I'm going to mark down, though, if I don't have a calculator, is for a good point, I know that this has to start. And it's not a vertex. It's an origination point. So normally it's at 0, 0. The reflection doesn't do anything to that. But then things were shifted left 1 and up 3.
Wow.
So we got a negative 1, 3 as my like origination point for, not a vertex. I don't even know what that's called. I'm a math teacher. So if I think about, okay, I need at least 1, maybe 2 more ordered pairs. I want to think about numbers that I wouldn't mind taking the square root of, right? So negative 1 works nice because when you did negative 1 plus 1, you got zeros. Taking the square root of 0 is awesome. Another number that's nice to take the square root of is a 1. So what if we plugged in a 0 right here? So if x equals 0, we input a 0. You get 1 square rooted, so 1, with a negative in front. So negative 1 plus 3, which is 2. And then another nice number to take the square root of is a 4, which means I don't want to put a 4 in, but what if I put a 3 in for an input? 3 plus 1 is 4. The square root of 4 is 2. So this is a negative 2 plus 3, which is a 1. Was that fun? No. Is it possible? Sure. Do I want to do it again? No. All right, 3, 1. And then we're going to get that shape, but we're going to see the reflection. We're going to see the left and the up
What's the reflection?
Reflection is where it kind of flips upside down like this.
Oh, right.
Yeah, like reflected in a mirror. But this time it's reflecting over this way. Cool, right?
If you have 1 million mirrors, what would it land on? You, the other mirror, the other mirror, the other mirror, the other mirror.
All right. Domain. Domain starts at negative 1. Goes to infinity.
Infinity mirrors. Goes to the other mirror.
The range, careful on the range, guys. The range is low to high.
So, why are you doing that range again?
Because the teacher asked me to do range. I gotta do it, man.
I don't like that word range.
All right, sit back, please. All right, range. This is weird because it goes down forever. So it starts at negative infinity. And then it goes all the way up until it stops at a height of 3. So again, notice that this vertical shift and part of the range, they go together. And then this horizontal shift and part of the domain, they go together. They should match up. You shouldn't have like a 1 here and a 2 here. All right, good deal.
You do level 1.
I don't know what that means.
Level 1 on math. Level 2 on math.
All right, this time we have a cube root.
XY.
XY. I need nice ordered pairs that I wouldn't mind taking the cube root of when I put the input in, because you control the input. You control the x. You can plug in whatever you want, but since I'm doing mental calculations...
Wait, so I can plug in the computer?
I'm not going to use a computer this time. It would be nice if I could actually draw...
Another computer? Or the piano?
Okay. Be silent for a minute. He's that kid in class, you know. You know who I'm talking about.
Oh.
All right, nice numbers to take the cube root of. Of course, everyone's favorite, 0. Putting in a 0 here would be awesome. Another nice number to put in would be 1, but also -1. And then the next nice cube root number would be an 8, or a -8. All right, so now let's figure out without a calculator what happens when you do these numbers into that function. So, cube root of -8 right here would be a -2. 2 times -2 is -4, and -4 minus 4 is -8. That is above your pay grade,
Oh,
Mr.
good.
Second
My
Grader.
hair's not sweating because of the pickleball.
All right. Plugging in a -1. Yeah, -1 cube rooted, which is also -1. So 2 times -1 is -2, minus 4 is -6. Plugging in a 0, that's nice. 0 is 0. 2 times 0 is 0. 0 minus 4 is -4. And then plugging in a 1, cube root of 1 is still 1. So now you have 2 times 1 minus 4, which is -2. Now, if all this mental math is like frying the brain, just grab the calculator, program it into y equals, and use your table. All right, 8. Cube root of 8 would be a 2. 2 times 2 is 4.
Meow, meow.
You got this for me. 4
Wait,
minus
what?
4 minus 4.
0.
Right.
Everybody will know that.
You'd be surprised. Okay, so -8. Oh, -8. Ooh. -1, -6. 0, -4. 1, -2. I forgot to talk about the transformations, Logan. All right, real quick. We got 3 transformations here. We have a vertical stretch. Yeah, we do. Look at that. Vertical stretch of 2. Then we don't have a horizontal transformation this time, but we do have a down 4 shift. Alrighty. Oh, why is it green? Oh well, go with it. Just go with it. That almost looked good. And what's my favorite thing about cube root functions? The domain and range, because they go forever. -infinity to infinity for domain, and -infinity to infinity for range. There you go. I think that was actually our last problem, Log.
Okay.
So, obviously much nicer to graph with a calculator. Can we do it without one? Yeah. Do I want to? No. But you're going to practice. And remember, you do have that free emulator that you can use on your Chromebook. So good luck, everybody.
Emulator.
Say bye, Log.
Bye.